Hi there. Okay, so I have this Xiaomi fan. This is very nice fan. There are a few special things about it. First, you can remove this cover and clean it easily. There is need to take it like this, and then it goes out. Believe me that it does. Sometimes it's a little here, and so you can clean it easily. And another nice thing about it that you can control the speed from low speed to high. The most important is that it is very quiet and uses a brushless motor. This is Xiaomi type. The disadvantage is that you need to supply power to its input. This is a micro USB. In order to get it to work, you need to plug the power bank, and then you can see that it is very quiet fan. You can control the speed. Of course, I'm talking about the minimum speed. The minimum is very quiet. You can hardly hear it at night, and this is the big advantage. And the problem is that you need always to have a power bank. This is what I don't like about it. So I thought that we will open it and add the battery inside. Of course, the cells that we will use will be 650 cells, like these cells. By the way, these are original ES2 cells. They are pretty safe compared to others, and I'm not sure that I will use exactly this one. I will see what we will do, but the most important thing that I can see by the size that it looks like it can fit in one cell, maybe even two. We'll open and try to see. So of course, when doing it, we will need to use some circuit in order to use like a power bank circuit inside. This is in order to charge the cell. So first, let's remove the stickers that are hiding, of course, the screws. We try to save them in order to put it back later. And we have 3 simple Phillips screws. Now, before opening it, I really don't expect to see something special other than just a circuit board that convert the power with this potentiometer to a 3-phase motor, brushless motor. Brushless is 3-phase. This one I expect to be 3-phase. We will see in a second how many wires are going to the motors. The number of wires is the number of the phases. So pretty easy to open, I hope. Yes, it's pretty easy. Wow. Okay. So first, I'm very surprised because they said when I bought it that it is brushless. Maybe it is still brushless, but here we have only, you can see we have only 2 wires that are going to the motors, because I have only 2 soldering balls here. Hope you can see. I will zoom maybe a little so it will be easier to see. Just a second. Okay, so now you can see better. I'm talking about the two soldering joints here, which are the motor power, of course. By the way, before doing anything, the best thing will be, by the way, maybe it is still brushless motor. Maybe inside there is a converter here from two wires to three. So maybe the motor itself can be still brushless three-phase motor. If I see the two wires, it doesn't say that it is definitely not a brushless. I'm not sure about what is inside. I don't want to open it, but it can still be brushless. It is interesting, but I don't want to ruin this one because it is a good fan. Okay, so before doing anything, the best thing to do is, of course, to take a picture. And why I'm doing it, because if you don't remember which wire was where, because of course, if you will flip the wire, so instead of blowing out to this side, it will blow to the other side. This is my guess. So now we will disconnect the wires and start working with it. So this potentiometer, of course, is changing the DC level to the motor. Of course, the higher the DC, so the higher speed we get. This is how it works. Very straightforward. So I now disconnect the wires, so it will be much easier to work this way. Okay, and the wires are just two wires. Okay, so by the way, we can see that there is a place to put the cell inside. We will take in a minute the cell and try to insert it in a moment. So, like a magic, it looks like it was planned. I have another kind of 18650 cell. It go inside perfectly, like it was designed, but look what is going. If I'm trying the other side, so it doesn't fit in, so I can't put two cells, I can put just one. Another thing is that this part of the fan is moving, so if you can see it, I will zoom out. Okay, it is moving, so the place it is moving is inside this square here. This is the movement. So now what we want to do is check the connectivity, check the voltage, and check the polarity. So let's do it. What I'm doing now, I will just connect the power bank, and I will use, of course, a DVM for doing the measurement. The cell is not interesting right now. We'll get to it later on. So I will use here my power bank, because you can't trust what is written in the board. You can't trust anything. Maybe the wires colors are flipped and you can never know what is going on. Okay, so let's measure the voltage. Okay, so Like I said, you can trust no one, because this is the red wire and this is the black, and the polarity is flipped. How do I know? Because the voltage here starts with a minus. If I will flip now the wire, so I will see that now the polarity is okay, 5 volt. Okay, so the power from here going 5 volts straight to here, but polarity is flipped. So now I know very important thing, that the polarity is flipped. I can use to put my circuit board here and the battery here, and we'll do all the connection, and we'll check that everything. One more thing that I forgot. Very important thing that I forgot. Okay, so I will explain. The power bank board is capable of delivering current. Usually, if there are very small ones, so 1 amp, the bigger 2 amp, and there are DC to DC of 3 amp. Why do I need this information? Because I didn't test how much power this fan is taking when it is using the full speed out, and I really need to know this number, and I need to measure it in order to know what is the current. So the best way to do it, there are a few ways to measure current, of course, but I have a preferred way. The preferred one, you can use it to cut the wire between and connect your fluke and everything, but I prefer the Hall sensor Unity, which is very accurate tool, and I need just to clamp it in one of the wire, and then I will know the current. So we will not skip this test, because it's pretty important to do. So now what I will do, I will connect back the wires in order to test the current. So let's look at my picture, because I already don't remember what is the polarity to the motor. By the way, it's not very important. To my understanding, if I will flip here the polarity, so the motor direction will be flipped, that's all. I don't expect anything else to happen. So we will do wiring and then do the measurement in a second. Okay, so I found a very simple wire. We'll of course solder the wires to the joints, because I need a more long wire in order to be able to connect the Hall effect current measuring. So let's do the test. I'll show how to do it. So first step, we'll connect it here to this side. Very simple test to do. By the way, this kind of wire of the motors are not regular, let's say, wires, because the wires that if you hit them too long, so eventually, I'm just connecting the opposite, eventually it will melt. It will melt the protection, and it can make a short circuit. So we want to do it very quickly, let's say about a second of soldering, not more than this, in order not to harm. Of course, remember not, and be careful not to have a short here in this kind of connection. So Now we will put the unit T in the place where we can measure the current. It doesn't matter to which wire it is connected. What you want to do, the number is flickering from my lamp here, so I will move it a little, so maybe it will be easier to see it correctly to the camera lens. And okay, what I need to do here is to press the rail. The rail will do calibration for the current field. So now we will put it to maximum power, and this is much less than 1 amp. Actually, I was expecting much more. 300 milliamps. Okay, what this information means to us is that no matter which simplest board you will use, the power bank board, it will be more than good enough. Okay, so now we are okay, and we have also another information. If I will use a 3000 milliamp hour battery, it can run for 10 hours continuously, which is a lot, and this is quite fascinating. I wasn't expecting this much. Okay, next. I have this very cheap power bank case that I bought a long time ago from eBay, or I think it was eBay. Up. So what we will do, of course, we will take the circuit out from here. Now we need to understand how it is going. So the battery is very simple, we can see where it is going to. The input is the micro USB. It will be instead of this input, and that's all. That's all we need to know. No, there is another thing that we need to know. Okay, so the another thing, because I don't want to disconnect part from here, I want to leave this connection, so I will want to connect it to this one, but what I don't know is where is the polarity of the input here. So in this case, we of course will do again measure with the fluke. What we'll do is very simple. We connect micro USB like to charge it, and we will measure where we have the plus minus 5 volt. Where we will have it, we'll have it on the capacitor here. Why on the capacitor? Because you're using the capacitor in order to regulate the voltage. It must be in the capacitor. I just need to know where is the positive joint and where is the negative joint. That's all. So running the fluke, connecting the power bank input. You can see it is also lighting the LED. And now we will check where is the plus and where is the minus of the 5 volts. Okay, so we don't have 5 volts, so this is not the correct point, because we need to have 5 volt sharp. Maybe it's because we don't have a battery, so it is down a little. So let's try to Connect here battery. Maybe the voltage will go up, I'm not sure, because it is a little strange to me, the low voltage. I expect 5 volts. So no, and no. So okay. Next thing is, because it's not on the capacitor, this is for sure the minus, the case, and now I will find where I have 5 volts. In what point here I have the 5 volts. Here, if you could see on this resistor, I don't know what it is, but it's not very convenient. Okay, so I will use I have here one joint with the 5 volts, so I will use this one. This one will be the positive here, and this one will be the negative, maybe 2 wires here. Yes, you can see now I have 5 volts, so I found 2 spots on the PCB that I can connect. This one is the minus and this one is the plus. It's very important information, because without this, if I will connect it to the wrong place, so of course it will not work, or it will burn, or I don't know what. Okay, so what actually I'm doing now, I'm doing the following. I will cut the wires here. I will remember that everything is flipped. Now I need to connect the 2 wires here to my PCB. Of course I will take this one out, I don't need it anymore here. I will take 2 wires from here to the battery soon, but this will be the last thing. And now I will do the connection with this wire. Oh, this is exactly what I didn't want to happen. You can see the wire with the case took out, but I need just the wire because I want to joint it, to solder it. Okay, so now taking it out, easily remove the plastic from the wire. Now I remember 2 things. First, the wire here was flipped. The black is the plus and the other is the minus, because I don't want to burn anything. So now I will do the soldering of this part. So let's zoom and do it. Now let's do the connection. So this is the minus and this is the plus. The minus will be the red because it's the opposite. Before doing it, I will add solder to the circuit. Also here, doing gently, not to ruin and not to short anything. You can hardly see what I'm doing. Okay, so this is connected already. Next thing will be to check the polarity out of this USB. This is the input, but this is the output. What I can do, let me think. Maybe the input and the output are the same wire. Maybe the input and the output are the same wires. I can test it, of course. How can I test it? Okay, I have an idea how to test it. So what I will do now, I will find a USB tester. I have one here. And what I will do, I will just connect it. This is the opposite side, so it's a little problematic, but okay, I can do it. And now we will check that. What we will check? Okay, I've seen that the input is 5 volt. Now, what I want to check. I know what I want to check. I don't need, by the way, this part. I want to check that if I'm connecting our battery, I want to see that the same wires that I've already connected, they have 5 volts also. Because it stopped working, let's try to reconnect it again. The problem is that I don't see anything, that I can't really catch it why it is, everything is connected. Try again, and no, I have here not the voltage that I need, so no, it's not the same input and output. Okay, so not yet done my work, because now we need to connect this output from here to these wires here. So let me just do a little test here. I know that the positive and the negative are the two sides of the USB, but I don't have a good way to connect it. So okay, we've seen that the power is very low, so what I'm going to do is doing the following. I will take a cable that is no longer working and I will use it as the USB output, and that's all. What do I mean? In a second, broken cable already. So what I'm going to do, let's see if it is fit in. Yes, everything will fit in perfectly. Just the other side. Yes, no problem. So I'm cutting it and using the wires as an output. Now let's cut the wire here easily, gently. Let's try to find a tool. this is a good USB. We have metals and everything. Of course we don't need this shit. So I'm removing the shielding and everything. I don't need it. I don't need the shielding here at all. And also remove all the metal parts. Metal and power are not going good together because it can do shorts. Of course the power here is the red and the black. You can see by the way that the power here is pretty wide, which means this is for high current. There is still many metals here in the place that I've cut, so I want to put a tape in order to isolate this part. I don't want it to show the battery or anything like this. Okay, so now left just with few simple things. First, I need to connect this wire to the wire here. Of course, don't remember the polarity is flipped, so the red will be to the black because the Chinese did a mistake. Maybe they did it on purpose, you can never know. Okay, so I will use these wires. By the way, you can see that this cable that I just cut was a bad cable, is very high performance because there are many wires and it's built much better than everything in this place, in the fan itself. Okay, so now let's again disconnect it. It will be easier. Okay. Oh, why the red wire has very few wires inside? I don't understand why it is like this. The black looks okay. The red not very good. Okay, this is how it is. What can I do? I didn't invent it, let's say. Okay, maybe no, I will connect it like this. Okay, so now we will do soldering part here. Don't forget to isolate everything you're doing. This is the most important thing. What I like to do is to put the tape on the first one, and then after 2 rounds you can put it all together and it is fully isolated. Okay, so now let's connect this part and connect this part, and then we just need to connect the battery. It's a little tricky how to connect everything, but I've checked it and we can do it. As you can see, it will fit in, no problem. Of course, we will cut this part. We don't need it. This will be here, like this, and then we will connect the battery and we will be okay. Now, last thing is to connect the battery and the fan, of course, and we are done. So how we will do it? We'll use the same wires that I found that is very good wire. I will use it also to connect the battery to the board here. Okay. Okay, so I have prepared the red and the black for the battery. So now let's see again the battery. I don't have a lot of space here, so I need to solder it with care. Okay, so I will now, before solder, battery will be the last thing, of course. So now I will solder these 2 wires to the plus and the minus of this part here, and I will cut again these clips here. I don't need it. So I have the positive and the negative for the battery. Plus and minus. Okay. Now we need to connect it to this part. Okay, so plus will be here, of course. Pretty hot. Now I will connect the minus. Now I will give you a tip. A very important thing to do before closing everything is to check that we don't have shorts. And what the shorts that I mean is between the two contacts of the battery that I'm going to put. So we will take the fluke and test that we don't have a short. If we have a short, then we are not okay. We don't have a short, so we are good to go. Now, before closing everything, one more thing to do is, of course, to prepare everything for the last soldering. Here you can see that here I am very close to the screw that is closing this, so I will take care of this and try to go a little away from the screw as far as I can. One screw is missing. I have two screws here, one here and one, so I need to avoid both of them. This is not very easy to do, but we will do it, of course. We can put it like this. It's a little problematic to do the joint of the motor, but I will manage. I managed to do so. What I'm going to do to take the wires from here, close it like it's all working. So we don't want anything to be screwed by all the closing part. Okay, so I can put it like this. Yes, no problem, I can do it. This I already used the heat gun, glue gun, and the glue gun is very important because I want to be able to close it, and this part is a little high like this. I'll catch it in another joint here. I will catch the wires. In a second I will move the battery wires to this side. It looks like it will be okay. Hopefully. We'll wait for the glue to be a little cold. It's a little difficult now to joint the motor, but I think I can do it. Hopefully I will not need to open anything. Okay, so the battery wires will go like this. I will put another joint of glue. Later we will fix it. We need to see that I'm close from the screw. Far from the screw, not close. But I'm not close. The screw. We'll put maybe some glue here. Yes, now it will be okay, I think. I'm not yet connecting the battery because I want to do it last. Okay, so now I will try to solder this back. It's not easy. But I think I have enough space. Try start from more problematic. Why did they do this wire so short? It's not very well designed, let's say. Okay, so now is our final test. Let's connect the battery and see if it is spinning. The positive is a little long. I don't want it again to short the contact, so I will short it and cut it a little. Okay, so let's see. Working. Done. So now just connect our cell and we are finished. So let's do the soldering here. It'll be much shorter. Positive one. Negative is okay. Zoom out a little. Okay, what I'm curious to find out is how to hell it is going to be closed. Like this. Okay, sync. I think I know, but I want to make sure that everything is can be closed properly. There was a little problem. The problem is that this USB was glued a little up, but I can smash it a little. Yes, and it will be okay. And it is also moving. So yes, everything is okay. So, really last thing. Soldering the battery. So I have two contacts that I left when I disassembled this battery from its battery pack. One is here, so it should be soldered. Yes, it is. And we said that here you need to do it very carefully, like this, a very small joint at the center, and here This is hot. Okay. Last part. By the way, another thing, when you're working with lithium battery, make sure they're almost fully discharged, about 3 volts or a little more, but not much higher, because if you will do a short, you want to avoid fire and things like this. So very careful with charged batteries. Try to do it when the batteries are almost fully discharged. Another tip to tell. Okay, we're okay with the battery. It is now inside. This wire should go like this. We don't want to smash it while closing everything. Another tip. Put the tape near the wires to catch them. This is the negative, so it's okay to connect it like this. Another one, pips of glue. Although the battery will not move anyway, because it is stuck pretty well here. If you can see, this is a little close to the screw here, but I can move it, and I'm thinking about it this way. We'll put another tape to catch it like this. And now we're good to close it. So again, how do I close it? Like this. So, well done. Job completed. Now I need to find the screws here. And they are here. Very well done. everything working perfectly. And that's all.